Okay, so I'm going to talk a little bit about how to design databases. And some of this I might save for after lunch or move a little more quickly too, but I'm going to kind of get to the, the good parts. Um, because I think it'll be really good to see and also kind of fun. So you're going to want to use, I would recommend everyone just starting with this tool called ERD Plus that I'll show in a minute for these diagrams, and I'll kind of talk about them. So modeling and domains, what is this stuff? So this is, we'll see this later, but this is just, I wanted to demo the ERD Plus tool. So here's a quick screenshot of it. And can everyone see my screen? Okay. Awesome. So a domain is a fancy word for some real world problem or scenario that we care about. When you're given a programming problem in an interview or an assessment or an assignment, that is basically a domain. And these higher level design skills that let us think more abstractly about our data model without worrying yet about like, what type is this column and where does my foreign key go, actually help a lot. So the goal of this is to give you all a design process that you can use this week in Postgres, next week in Django, and for your personal projects to design your data models and your databases that should help make that easier. And the tool is what's called entity relationship diagramming, and you can use it for all sorts of stuff. And I'm going to break this down in a minute, but just to give a preview, this is an example of a somewhat more complex entity relationship diagram. And this is modeling, it looks like sort of a company and inventory. And you can see there are these things, employees, and they have these properties like first name and last name, and employee works for department. So we have entities and relationships. So as software engineers, we're modeling or simulating the real world. We're modeling a domain, a real world problem area. And we'll talk about software engineers having domain knowledge. For example, if you end up working on like anything involving money and financial transactions, there's all these little rules and things you need to be aware of. And that's domain knowledge. Or another area is actually like logistics and like shipping. Like there are a bunch of companies out there, ShipBob, Amazon, Flexport, UPS. And so just even outside of the software engineering skills, just knowing that world and those rules and how that works, like that often your career can go in a direction of a particular domain. Because really we're modeling the real world with software. That's where it has value, with object-oriented programs, with databases, and so on. So a data model captures how we organize information about the stuff we care about in our domain. It's easier to start designing this stuff at a higher level of abstraction. Don't worry about if customer email should be a varchar with 100 or 255 characters. We want to start at a high level. And there's actually a whole process for this, and this is just a very lightweight introduction. A data model, you can break it down into three parts. A conceptual model that identifies concepts, and we're going to see using an entity relationship diagram to build that. A logical model that defines our data structure, and that's like the data schema that you all just built. And then there's the physical level, and this would be like even lower level Postgres stuff, like indices on where on the hard drive things are stored. And there's some flex, like when we get to Django, we start working with Django models, and that sort of becomes the logical part, and we don't even worry about writing SQL ourselves. But it's useful to think about like designing data models in sort of these three stages. And you can kind of use this for other stuff as well. And the physical layer we usually don't care about. Like you could use this to design an object-oriented program. You could use bits of this sort of maybe for React. But there's a lot of useful pieces here. So the bigger our programs get, the more important it is to plan. As the assignments and assessments get bigger, planning up front is more important. With SQL and with databases, it's not always easy to spot a bug or a design flaw. Planning eliminates bugs before they happen. So that's our goal here. So this tool called entity relationship diagrams lets us do this. And give me one moment, actually, I just need to move my screens around a bit. I'll show the diagram in a minute, but the concept is pretty straightforward. Entities are things, right? Customers, purchases, items, people, places, things, organizations, events, or concepts. So we've got entities. Entities can have attributes. Here's a student entity with a bunch of different attributes. Let me make this a bit smaller. Our student has a name attribute, a date of birth attribute, an address attribute that has all these other things. And if this is starting to remind you of tables and columns, that's the idea. Entity relationship diagrams have a couple different notations. The most important one is this dash under something means this is unique. Or this line rather. The dashed oval, I believe, means optional. I don't remember the double ovals actually what that means. I'll look that up. And you can have these sort of composite attributes, right? So the idea is let's think about this as a high level before I worry about should the address be its own table or just included on the student table. Let's think about this at a higher level with entities and attributes first. And I just sort of list here the different kinds of attributes you can have. The next important piece is these relationships, right? A student enrolls in a course. And in fact, let me just go ahead and build this right now. And let me go ahead and log in. Apologies. And let's do a new diagram. We'll just call this Victor. So we've got a student. We've got a course. Can everyone see this okay? And a student enrolls in a course. And the reason I want everyone to use this ERD plus tool because it gives us this nice thing where we can say the relationship. And let me ask you guys, is this a one-to-one relationship, a one-to-many relationship, or many-to-many relationship?
The one-to-one.
Many to many.
It is a many-to-many. Why is it a many-to-many?
Because a student can be in multiple courses and a course will have multiple students.
Yeah, exactly. So that's a good guess about one-to-one. And I think you're thinking sort of about like, hey, if we do a query and we join, there's going to be one student row for a student that matches to one row for their enrollment in that course. And that's correct. That on some level that's happening. But in terms of the relationship between these entities, a course can have many students in it, and a student can enroll in many courses. And we'll see tomorrow really how to model this with tables. We haven't seen this yet. The short answer is you need what's called a join table that would be like enrolled in, and it would have the student ID and the course ID. So there would actually be a third. There's actually another table here that we don't see in this diagram, but we'll see that more tomorrow. And then I can add attributes. You know, I can add an attribute. I will just call this name. And we'll just say it's unique, and actually, that's the better way to do it. You click on the entity and just add the attribute. So actually, we'll have this be email. So you can build this up very nicely, is really just what I wanted to demo, that this is a useful tool. So we can build these relationships. And so to kind of like expand on these relationships a bit, these three sort of crow's feet mean many. One is with this this crosshatched line right here. And so a student can enroll in multiple courses. A student can only have one locker, and a locker in our universe can only have one student. And that's a design decision we make, right? At some schools, maybe students share a locker. So that's a good example of domain knowledge. A teacher can teach multiple courses, but a course can only have one teacher. And again, that's a domain knowledge question. Maybe some courses can have two teachers, but not in our universe. So we can have these one-to-one or one-to-many or many-to-many relationships. There is a good article I linked to from this Geeks to Geeks site that goes into entity relationship diagrams in detail. But we don't need to get too much into the nitty-gritty. It's cool, but it gets a little complex. I really want to use it at a high level, because here's what I want you all to practice. Figure out your conceptual data model with an entity relationship diagram, and then figure out the actual classes and tables and SQL, the logical data model. And even though it's a little artificial, I want you all to practice this to build up this skill, both because this is a core software engineering skill, and because as our projects get more complex, this will help you with your design process. And so from both my own experience, and actually there's a pretty good paper on this, there's actually a pretty explicit process for how to do this. To build up our entity relationship diagram, start with some sentences just describing stuff. And we call these stories. And the example here is a customer should be able to buy an ice cream cone. A story should have a verb and some nouns, right? And that's like our entities and our relationships. Write down what you need to store in the database. Write down in a couple sentences what we want to find. I want to be able to find how much ice cream was sold on a particular day. So this is sort of exploratory. Identify our entities, put them on the diagram. Like we've got a professor, we've got a teacher, and we've got a locker. Don't worry about relationships yet. Once we have our entities, now let's add some relationships. We're not going to worry about one-to-many or many-to-one. We're just going to figure out the relationships. And this is a whole lot easier. Right? If you break it up this way, life starts to become simple. Now we identify the relationships, one-to-one, one-to-many, and so on. Right? A teacher teaches one course, many courses. A course only has one teacher. A student only has one locker, and a locker only has one student. Then we identify the attributes. You don't have to go over the top here. Then figure out your identifiers, i.e. the primary key for the entity, and then start thinking about your primary and foreign keys. And now let's build our data model. Our entities become tables. Our relationships become primary and foreign keys. We'll see tomorrow really how to do a join table for many-to-many relationships. So we might need a table here and there that's not an entity. Create some fake data to help figure stuff out. And then start adding columns into tables, insert the fake data, add some constraints, and run some queries. So really this week for all of the assignments, we'd like you to practice this process explicitly. And actually for each of the assignments, an entity relationship diagram screenshot is going to be required. And we may or may not do that for the assessment. The entity relationship diagram doesn't have to be perfect. I do want you all to practice doing this, even if it feels like an extra step. So I know I just covered a lot of ground there. So I do want to pause and check in and see what's on people's minds or what questions folks have. Okay, cool. So ideally, really, I would love for you all to create entity relationship diagrams. And I think I have, oh, it's somewhere else, unfortunately. And I would love for you to use Draw SQL or one of those other tools to create data schema diagrams as well. Documentation is actually a big part of being a software engineer. And I think it'd be really useful for all the assignments, but definitely the entity relationship diagram. And so the assignments for this afternoon are going to be really around designing schema. There is a short article to read talking a bit more about this. There's a little bit I didn't get to today about databases that I'll give as, I think, assigned reading. But really the assignments are building and designing schema. There is a tutorial of designing a blog that walks through building a blog. And so I think it'd be useful for all of you to do and code along with this tutorial and build an entity relationship diagram. And more interestingly, I have a more open-ended task for you all. And this is an assignment we're going to be returning to throughout the week. There's an ice cream store, 32 flavors. And it's had a meltdown and all the records are gone. And the records were in books. But the owner of the store, whose name is Daldis Bumbledore, so there's a little bit of a theme going on here, has decided we want to use computers, and they've decided to hire you to build the system, specifically the database and the data model for sales and inventory and employees. And I've kind of broken this into stages and given you some advice in terms of keeping it simple. So there's a couple steps here, but essentially you need to build a simple entity relationship diagram for like the inventory of buckets of ice cream and boxes of ice cream cones, and a little bit about sales and a little bit about employees. And as we go on, we'll start adding like multiple store locations. But for today, it's just stage one. So for this, I do want you all to design an entity relationship diagram and then build a data schema. And then we'll sort of be building on this as we go through the week. So those are really the main, and then there's also an assignment to design a schema for Instagram. And I would like you to do an entity relationship diagram for this as well. So this is actually a good amount of stuff for today, these 3 tasks. If you want to dive into this 32 flavors one, go for it. I would say this is sort of the heart of it. But this blog schema one is really a tutorial walkthrough. So if you want a little more practice and to sort of like see this process in action a bit, you can start here. And then I would say do this Instagram one after you've done the 32 flavors. But the goal is try following these steps in this process. So now is definitely a good time to stop because I did run a bit long. But I just sort of wanted to walk through that piece. And I'm more than happy to go over that again after lunch with folks who want to as well, because I know I did squeeze it in there at the end. So thank you all. And before we break for lunch, do folks have any questions? Okay, awesome. Thank you all. I will say, if you didn't get to the Postgres tutorial, that is an excellent assignment to do independently, especially if you won't feel like you want a little more hands-on practice before diving into designing schema. And again, I will be around after lunch if anyone has any questions or wants to go over bits of this again, or do like a little review session or anything. So let me stop the recording.